Okay, welcome back. Now we're actually going to get to use this rule. I'm looking at the top of page 19 of the Polar Packet now with example 5, and I've recopied the rule we went over that was at the bottom of the page before. The only slight adjustment, this isn't that big of a deal, but instead of writing 2 pi k up top, I wrote it as 2k pi. Let's see how this plugin is going to go. Find the square roots of this complex number. Okay, now we got to think for a second. First of all, how many solutions are we expecting to get? This says square roots, so there should be 2 square roots that we can find in the complex number system. Here's what we're trying to do. We're trying to find z sub k such that if you square root this, you'll get that answer. So negative 2 plus 2i squared to 3 to the 1/2 power equals our solution or solutions. So I want you to look inside of the parentheses. And step 1, if this shortcut's going to apply, we need to see this complex number in polar form instead of rectangular form. So think for a second. Let's think about a quadrant that the inside would fall in. Negative 2 for the x, and then up 2 squared to 3 for the y. A negative x and a positive y lands me in quadrant 2. Keep that in mind. What would r be? I can use the same exact conversion methods I've always used. R equals the square root of x squared plus y squared. So x is negative 2. You square that, you get 4. Plus y, 2 square root of 3 squared, gives you 4 times 3. All said and done, this will be the square root of 16. So r in this problem on the inside is going to be 4. Then the theta. So theta equals, well, the tangent of theta should equal y over x. So I need theta to be the angle that has a tangent of, what's the y? 2 square root of 3 divided by negative 2. I need an angle in quadrant 2 where the tangent is the negative square root of 3. And we're going to use theta equals a pi over 3 reference angle, but in quadrant 2, so 2/3 pi. 2 pi over 3 for your initial theta. All that side work to get this into polar form. So now here's what we're looking at. An r cis theta raised to the 1/2 power. So we said r is 4, cosine plus I sine abbreviation, and theta is 2 pi over 3 to the 1/2 power. And de Moivre's theorem would be a really quick way to get our first solution, just to take the power of a complex number, but we want both solutions. So we want to find z with a couple subscripts. So I will apply this rule next, z sub k equals, and de Moivre's theorem, or the rule above, says to raise 4 to the 1/2 power, so square root the 4 and get 2, cis. And for our new theta, we've got 1/2. I'm just applying the rule that I see above. 1/2. We'll have the original angle 2 pi over 3 plus, I'm going to say 2k pi. I'll put that there. And then that 2 is the n that's on the bottom in this rule. I'm going to bring it into both parts carefully. It'll be z sub k equals, we'll say 2 cosine plus I sine, bring in the 1/2, and you get pi over 3. And bring in the 1/2 to this part, plus k pi. That should do the trick, just dividing that whole expression by 2 to get what's in. In order to get both square roots, we're going to evaluate this for 2k values, from k equals 0 up to 1 less than the type of root it is. It's a square root, so I need to evaluate this for k equals 0 and 1, just to keep that in mind. All right, so let's do the plugin. Now, for practice, we're going to get these answers in polar form, but I also want to see them in rectangular form. So this is, let's do z sub 0 first. 2 cosine plus I sine, I'll put cis for starters, pi over 3 plus 0 pi, so just pi over 3. Okay, there's your polar form solution for the first square root. We want a rectangular form solution with exact values involved. So 2 cosine of pi over 3, we're just writing the whole thing out, plus I times the sine of pi over 3. Okay, exact value time. So this is 2 cosine of pi over 3, right? We'll just think to our unit circle and get a 1/2, plus I times the sine of pi over 3, a square root of 3 over 2. So first answer, when all said and done, 2 comes in, you get 1 plus I square root of 3. And all these answers are absolutely able to be checked out because we could square this in rectangular form, and the answer we should get would be equivalent to this original expression. Let's get the second and final solution, z sub 1. Can you plug in a 1 for k? So z sub 1, it's 2 cosine plus I sine, and then you have pi over 3 plus pi, right? Plus k is 1 times pi. And we'll make that 2 cis 4 pi over 3 for finding an exact value. So 2 cosine of 4 pi over 3, that sum, plus I times the sine of 4 pi over 3. 4 pi over 3, now we've moved over to a quadrant 3 angle where both the sine and the cosine should be negative. And we'll have the same numerical value, same absolute value. For the cosine of 4 pi over 3, you should get negative a half plus I times negative square root of 3 over 2. So second solution, squeeze that in there, negative 1 minus I squared root of 3. Plugging in any higher integer values of k will just get you redundant solutions. You can actually graph this solution on the unit circle, and not really the unit circle. I'm going to call this the 2-unit circle. The radius of this circle is 2. And both solutions fall along this circle. One of them is in quadrant 1 at pi over 3. We found one solution here. That is z sub 0. And then if we go all the way around to the 4 pi over 3 angle, the quadrant 4 solution, you get z sub 1. And don't bother going any further with this. We found the 2 distinct square roots. The very next answer that would come up if we found, say, a z sub 2 would be redundant. It'd be back where you landed with your first solution. Now let's skip down. Last but not least, let's look at number 7 on the next page. And then just as a heads up, have your calculator handy for this one. We'll probably find a spot where we can use some approximations. It says find the 3 cube roots of the complex number negative 2 minus 2i, thereby solving this equation. We want the cube root of that original complex number that's given. So let's find it in polar form. That's what we did first last time. Let's get a sketch of this. What quadrant are we in? Well, we're over 2 negative on the x. We're down 2 negative on the y. Your best bet for a theta value in this quadrant, just without even writing out the conversion, just knowing you went down and over the same amount, creating an isosceles triangle, would be 5 pi over 4. So use that as your theta. How about your r? I can always trust that r equals the square root of x squared, so negative 2 squared, plus y squared, another negative 2 squared. I'm going to leave this r, I'll show you why in a second, as the square root of 8. I know that's also known as 2 squared root of 2, but a lot of times with these questions, there's no need to simplify exact values until the very end, because in a second, I am going to cube root a square root. I'm going to take the square root of 8 and cube root that square root. Let's see how that'll work. So go back up to the original, but now in polar form instead of rectangular, and we want z sub k to equal, what was r? So r is square root of 8, cosine plus I sine of that theta, 5 pi over 4 to the 1/3 power. Okay, so here is the work we'll show. Z sub k, we'll write this once more, the cube root of a square root, right? That's going to be a 6th root. This is going to be an 8 to the 1/6 power. We're going to end up using a decimal in the calculator, but I'll write that as the 6th root of the number 8, tiny decimal. Cosine plus I sine, now let's use the rule here with that 2k pi included. So it's 1/3 times the original theta, we'll simplify that in a second, plus 2, I like to write 2k pi on the inside of there too, because we are adding a couple integer multiples of 2 pi. Let's do z sub k equals, trying to keep this neat, 6 root of 8, cosine plus I sine. I just want to bring the 1/3 into the set of parentheses. So it'd be 5 pi over 12 this time. So we're kind of out of our exact value realm. And then plus 2k pi thirds, or pi over 3, with that 3 coming into both parts. This is going to be your guide as we find these 3 solutions. Which k values do you care about? You always start with 0. So for one of them, we don't have to add any multiple of 2 pi. And then count up the integers until you get to 1 less than the number of roots you're looking for. So 0, 1, and 2 should get the 3 distinct solutions to this problem. I'll put this underneath. Let's find z sub 0 first. And we'll do it in polar form and for practice rectangular. So z sub 0, the 6 root of 8, cosine plus I sine. So I'm actually going to write this out the long way, cosine of 5 pi over 12 plus 0. So 5 pi over 12 plus I times the sine of that same angle. I want to show you something cool on the calculator. If this were on a quiz or a test, for me at least, the directions would say approximate your answer in rectangular form to maybe the nearest thousandth. So the calculator is going to give us a little bit of relief here. I'm going to go to the calculator and type it in as I see it. You can find the sixth root on the math menu if you type in the 6 first, use that number 5, or I might just not want to fish in that menu, and I'll raise 8 to the 1/6 power. So that's good for starters. Now this I think is pretty cool, and I think you're going to like it too. I'm going to use the calculator's I key and be lazy, type this entire thing in, and then get some decimal approximations. So I'll start a set of parentheses. I should have done this first. Make sure your calculator's in radian mode because we're answering in radians. And then I'll do 8 to the 1/6. Let's go cosine of, what was our angle? 5 pi over 12. So 5 pi over 12. Close the parentheses, plus, now here's the cool part, or what I think is the cool part, second, and have you used the I key? It's the decimal that's down at the bottom. So second and the decimal for I, and then the same thing with sine. Sine of 5 pi over 12. Hit enter, and we're going to round this solution and find 2 more. So we're going to use, this is our approximation, 0.366 plus 1.366i. Write that approximation in polar form. So 0.366 plus, we'll say 1.366 times I. Okay, that is our first solution, and we'll graph these as well. Z sub 1, 1 down, 2 to go. Second one, 6 root of 8 still. Cis, again, I'll write this out. You're going to add 5 pi over 12 plus 2 times 1 plus 2 pi over 3. Well, that's like you already have 5 pi over 12, right? And then if you're adding 2 pi over 3, that's like adding another 8 pi over 12 to get 13 pi over 12. You can check that for the second argument. And then sine of 13 pi over 12. And there's your answer in polar form. Rectangular, I can just bring up the previous entry. I can go up with my cursor and grab it. Or if you hit second and enter, the previous entry pops up. You can use the cursor to go in and edit, and even the insert key. I can go 1, and then I have to insert second and delete, and I'll insert a 3. 13 pi over 12, I got to do that once more. So one more time, 1, second, and insert a 3. Hit enter. I mean, that wasn't too bad. You get your second approximation. This one came out to be negative 1.336, and actually I mixed that up in the first answer, didn't I? It's 366. Sorry, doubting myself here. Negative 1.366, and this one was minus, I apologize for the handwriting, 0.366i, like that. And one last root to find, z sub 2. You would just get this in a very similar fashion on the calculator. I'll write it in shorthand. 6 root of 8 cosine plus I sine. If I add 4 pi over 3 to pi over 12, I get my final theta of 21 pi over 12. 21 pi over 12. And then go ahead and type that into the calculator for yourself. Actually, this one's so cool, I should do it. It's just like a nice little final solution. Second and enter. If I just change those 13s to 21s, just for the joy of this. I love when an answer just comes out nice and neat. 21. And lo and behold, I didn't expect it. You get 1 minus 1i. 1 minus I. So not a lot to write out for the third solution. You can also visualize these solutions by graphing like we did in the last example. I drew a little circle here, and the radius of the circle is the radius of your answer, the 6th root of 8. That's how big the circle is. Your first solution is drawn by this first red line here. It's up in quadrant 1 at an angle of 5 pi over 12. The second solution is just past 180. It's at 13 pi over 12. So this is z sub 0, where it would fall graphically. Here's z sub 1. And the third one is an angle of 21 pi over 12. You have a quadrant 4 angle. So z sub 2 would be there. Enjoy your day. Talk to you guys soon.